It goes up a little bit, right? It goes up to 1, and then it comes down like this, right? And then here's y equals 1. So where is your, you can turn that, oh, never mind.
But
this is
made of 2 lines.
That's true. I know, we're going to break it apart here. So this is f of x right here. So what's this distance right there? 1 minus f of x, right? And what's this going to be? 1 minus g of x. So you really have two things here. You have this one right here, and then what else do you have? That one right there. You have two different regions. It changes. The how you define little r has to change because the boundary for little r switches functions. Does that kind of make sense? So you have your outer, which is going to be one. You can do it in two sections here. So they go from what? Oh yeah, it also says that this is x equals 1 right here. Yeah, does it start at -1 right here? So what's our first region? Our first region is going to go from -1 to 1, and what are you going to add to it? From 1 to what? Looks like it goes to what? 2 right here? From 1 to 2. So what's the first one going to be? It's going to be pi 1 squared minus what? 1 minus, well, f of x here, squared dx, right? And then the other one's going to be 1 squared minus 1 minus g of x squared dx. So you have to break it apart into two. The lower boundary changes. The other thing they like to do on rotational solids is the boundaries might flip. They might go up, they might oscillate a little bit. And a common thing to do is not to switch it or break it apart into multiple, and you get a weird, cranky answer.
Why is this?
Because because when you have this right here, how do you find the area? And if you know that this right here, so I'll try this. If this is big R right here, and this is little r right there, you have pi r squared minus pi r squared, right? So it's pi times r squared minus like this. You have to square each of the radii, not the entire thing. A really cool, a really common way to like fool you is to just put the squares on the outside. You know, it's that standard algebra 2 thing. You know, is this equal to this? No, they're not. You know, it's also just not it's not something I think you think is true, but when you're reading it, you have to be very careful to read it correctly because you're like, oh, the squares are there and the radii are there, but the squares are in the wrong place.
And why is there pi?
Differentiate with respect to t?
dy dt, I think this is what it is. It's been a while. dy dt times 1 over cosine squared y.
Hold on. What is the derivative of tangent? Yeah, so let's just say secant squared. I like putting it front. So it's secant squared what?
Y.
Times what? dy dt, correct. Plus
dx.
Yeah, you interesting. See, this is
Oh, you're right. Yeah.
no. This is exactly why I really like doing the AB stuff with you guys to understand some of the ordering and the terminology.
Okay, so 3x squared.
3x squared dx dt. I like putting it at the end. Yep.
And
Equals
and that equals
2y.
Yeah, 2y dy dt.
Plus anything?
Nope.
No, exactly. So we want dy dt. I always like, you know, when you have a highlighter, I like to think, okay, we're looking for this right here. So we have to plug in a whole lot of other things, right? What do we know? Do we have one of these at least?
Yeah.
We have this. dx dt is
-2.
-2 right there. Great. But we have to plug in everything else. How do we go about plugging in? How do we go about finding everything else? Oh, we have a bunch of it already, don't we? So where's that? That's an x value. So that's going to go right. Oh, it's going to go right there. Nice. Any other x values? Nope. What about y values? Yeah, y values are in there. So y is right there. Goes right there.
Yeah.
And it goes. What's cosine of 0?
It's
1. So it makes it defined, right? So what does that turn into?
dy
1 squared dy dt plus what? 3 times dx dt, which is what? -2 what, though? Squared? No, that's, I'm sorry. No. I'm sorry. I got it. It's, what is x? Sorry. X is 1, sorry. 1 squared times dx dt is -2 equals 2 times 0 dy dt. I just like writing it out even though a lot of it's going to cancel. So this right here goes away, right? So what do you end up with? Dy dt minus what?
minus 6.
Equals 0, so dy dt is equal to? That's kind of cool. I like this one. I love ones that you sense like, oh, I'm sensing a clean answer. So nice. Like, compared to the answers we've been getting, this is like sterile from space. Nice,
Yeah,
you know? You know? So that's why so f prime of x is going to be what? 3 minus
10 sine.
3, because what's the derivative of cosine?
Right, plus.
Plus. So what's f prime of 0 going to be? 3 plus 10 sine of 0. What's sine of 0? So it's going to be 3. So you have y minus y1 is equal to m, which is 3 times x minus 0. So you need to find y1. How do you go about doing that? y1 at 0 is going to be 3 times 0 minus... What am I doing right now, Tori? Yeah, but I have to find the y value when x is 0. So I'm plugging it into the original equation. You see that right there? Minus 5 times cosine of 0. What's cosine of 0? So you have 0 minus 5 times 1. So you have what? Negative 5. So you're going to have y minus negative 5 is equal to 3 times x minus 0. That's just point slope, right? So then you have y plus 5 is equal to 3x. So y is equal to 3x minus 5. D. Is that cool?
Yep.
Yeah.
Let me check out.
Okay, a particle moves along the y-axis, so its position anytime t is that. In which interval is the particle speeding up? Now, this is just something you have to remember. This is a great question to ask about because you just have to remember this. My guess is the mechanics of this. You understand like all the different things you could do, but what does speeding up mean? Not what you find. I'm not asking how to find it, but what does it mean? Acceleration is a noun. So a particle is speeding up when what is true? Yes, speed. Yes, correct. When what? When what?
Velocity and acceleration has the same sign.
Yes, this is when velocity and direction same sign, right? Because look, listen. You can be moving forward and speeding up. Look, you could be moving forward and speeding up. You can move backward and speeding up, right? But velocity moving backwards is negative, correct? So velocity and the direction you're going in have to be going in the same sign. Does that make sense? Oh wait, not velocity and direction, velocity and acceleration. Sorry. Well, not okay. Ready? I'm still. Should we do this one then? Is that okay?
I know.
You want to do it? Okay. So our position, right? Tori, this is only going to drive us really crazy. Okay. So there's our position, right? So what's our velocity going to be? 4t cubed minus 36t. And then a of t is going to be 12t squared minus 36, right? So what you have to do on these is find out when these have the same sign, right? And the best way to do that, I literally make a little line graph like this, right? Yeah, so on these, can you factor out a bunch of things? Yeah, you factor out a 4t, and what do you end up with? T squared minus 9, right? And what is that going to be? 4t times, t plus 3 times t minus 3. So what points do you have? You have 0, 3, and negative 3. And then on the bottom one right here, what do you factor out? 12 times t, I'm not done yet, minus 3, right? Like that. So what are the zeros on this going to be? T plus root 3 times t what? Minus root 3? Are you with me so far?
Yep.
So where do you label these? So you know you don't have a 0 on here, but you have square root of 3, which is going to be like negative root 3 right there and positive root 3. I'm lining them up. So then what do you have to do on these? Find out what?
You have to find out where it's positive.
Where it's positive and negative.
You also cut off after 0 because it's only asking between 0 and 5.
Exactly. Oh, that's fantastic. It's 0 and 5. Fantastic. So you go only going from here onward like this. So you just need to find the sign, and then where do they have the same sign? Negative and negative, or positive and positive. The x-axis, at which time on the velocity versus time graph given above is the particle farthest left of its starting position? So left means it's going to be left of its starting position if the velocity is negative. It's moving away, like backwards if it's negative. Does that make sense, everybody? So what's going on here? This is the velocity graph, right? So tell me what's going on. The particle starts moving right there, right? And here's the velocity graph. It's negative. So is it moving forward or backwards?
Backwards.
So it's moving backwards from here to here, right? At point E, what does it start doing? It turns around, right? So it's moving backwards all the way to E. So when is it furthest left? It is furthest left at E. Yeah, absolutely. Right, yep. dy dx is equal to this thing, right? Yeah, once you see it, so now what do you have here? You have dy, look, dy over y is equal to 3 plus 1 over x, not dy, dx, right? So what do you have here? Y to the negative 1 dy is equal to 3 plus 1 over x dx. Now what do? You anti-differentiate. What is, okay, so what is the anti-differentiation? What happens? What do you end up with?
Yeah, and then y equals.
ln what?
Y
Equals that thing.
3x
3x plus ln what? X, right? But then what do you have to do?
and then
So you know that y is equal to e to this thing, right? ln x. But then you have to simplify. You have to know your simplification rules, right? So this is e to the 3x plus, so it times e to the ln x, right? Because you add when you have powers like the same base. But what is e to the ln x equal to? What is it equal to? X. So y is equal to x e to the what? 3x.
Which is none of these.
Is that any of those?
Nope.
I got it right.
Wait, I got it right
For the wrong
too.
reason.
About this. When you anti-differentiate, what did we forget about? This is where, remember how you always add plus c and you're like, it never matters, we have to put it in anyway. In this case, it really matters because it generates a coefficient here. Because when we took this is really important. When you took this, you ended up, we anti-differentiated right there, correct? So you end up with a plus what? C. So you end up with a plus c, so you end up with e to the c, right? So this right here is a constant, correct? So what we really have here is, we have y equals, like big A, exactly. You could call it A if you wanted to. Absolutely. So ax e to the what? How do we find out what A is? 1, 2. It passes through the point 1, 2. So 2 is equal to A 1 e to the 3. So what's it going to be equal to? Wait, did we do this right? A. Did I plug that in right?